This video is on the objective interpret the slope and y-intercept of the least squares regression line, right, or that best fit line to a scatter plot of data. So yeah, this is just simply a video where these are problems where you're just again, it's in the title of the objective, interpreting what the slope means in the context of the problem, and also interpreting what the y-intercept would mean in the context of the problem. Alright, so again, if you want to see more about the topic, click on More Instruction, look at their notes, their videos, their examples. Hopefully those help you. In fact, I'll show you some of the notes here. Right, now first they go over something you should be familiar with from an algebra class, right? The equation of a line. Now we're going to be looking at lines in like slope-intercept form all the time. Y equals mx plus b, where remember the number attached to x is called the slope. The coefficient of x is the slope m, and the y-intercept b is the y-coordinate of the point on the y-axis. Right. Remember the y-intercept always has an x-coordinate of 0, because you just plug in 0, substitute 0 for x, and you get y equals b. That'll be the point on the y-axis, the vertical axis. The slope m between 2 points is defined as rise over run, right? It can be calculated by finding the change in y divided by the change in x, right? Delta y over delta x, rise over run. I'm hoping all this looks familiar to you. And this slope number just tells you how to travel on the line. I'd go, the run tells me how far right or left to go, and then the rise tells me how far up or down to go to keep on the line. I go right delta x and then up delta y, right delta x, up delta y. Right. So how do you interpret the slope of a line? The slope of a line represents the rate at which the vertical coordinates increase or decrease if it's negative. Remember, negative slope means as I move right, the y-coordinates are decreasing, when the horizontal coordinate is increased. The units of slope are always the vertical units divided by the horizontal units. So in the graph below, the horizontal units are in minutes. Right? You have a distance versus time graph here. The horizontal units are minutes. The vertical units are miles. So slope here, this 3/26, right? The number on the t, I know it was not x, oh man. But the number on the variable, right, 3/26, that's the slope, and it would be 3/26 miles per minute. Right. See, the slope is 3/26 miles per minute, vertical units over horizontal units. Meaning that for every increase of 26 minutes, the distance is increased by 3, right? It's rise over run. If I run 26, increase the time by 26 minutes, the rise would be positive 3. I'd increase the distance by 3. So right 26, up 3. Right 26, up 3. If the slope were negative, if it were negative 3/26, then the distance would decrease. The y-intercept is 0 here, and it's crossing the vertical axis at 0, which implies that when time equals 0, distance is 0. Right, I'm hoping all this sounds familiar, right? So here, interpreting the slope and y-intercept of that best fit line, right, for a scatter plot of data, the least squares regression line. So remember, the least squares regression line is the straight line that best fits the data in a scatter plot. The least squares regression line can be used to predict the value of the dependent variable y for a given value of the independent variable x. The regression line takes the form of the equation below. Now remember, for the line, and you've seen this in earlier objectives if you've been watching my videos and reading this stuff, they use y hat to represent the y-coordinates on the line, right? Because these are not the same as the y-coordinates in the actual data points. So you have y hat equals mx plus b. In this equation, m is the slope, b is the y-intercept. Y hat is written in the equation instead of y to indicate that the equation gives a predicted value of y, right? Not the actual value of y. So the slope of the least squares regression line gives the change in y that is predicted to occur on average when x increases by 1, just like any slope. If the slope is positive, right, then on average, y is expected to increase by m units for each 1 unit increase in x. If the slope is negative, then on average, y is expected to decrease by the absolute value of m units, right? Make it positive and then go down for each 1 unit increase in x. The y-intercept of the least squares regression line gives the value of y predicted by the model when x is equal to 0. However, the context and type of data being analyzed must be assessed before providing an interpretation of the y-intercept. If in the problem it is impossible or doesn't make sense or it's unreasonable for the value of x to be 0 in reality, then the y-intercept has no meaning, right? It has no meaningful interpretation. It should not be interpreted at all. Similarly, if in the context it is impossible or unreasonable for the value of y to be equal to the value of the least squares regression line's y-intercept, right? Say it ends up negative when you should have, you can only talk about positive values or something, then the y-intercept should not be interpreted. So this, we'll talk about examples like this when I get into my problems. Right? Then they have examples that you can read on your own. I'm going to let you read those. Let's just get to a problem. All right, now this one is just a simple multiple choice deal. So which of the following data sets or plots could have a regression line with a negative y-intercept? So meaning that when the value of x is 0, right, the y-intercept on the line is negative. The difference in height between two twins, shorter twin minus taller twin, plotted as a function of age. Well, if you take the shorter minus the taller, that could end up, that'll always be negative. Right? If you're always taking shorter twin minus taller twin, those will always be negative. Now, as a function of age, does it really make sense to talk about the y-intercept? Now, age 0, right? Age 0, they're not born yet. Right? You could talk about when they're newborn. Maybe you could do that. When they're age 0, take the shorter baby minus the taller baby when they're immediately born, and that would be negative. So I'll leave this one as a possibility, even though it kind of doesn't make sense to me having age 0. Right? Let's see if it makes more sense though than some of the other ones. The number of people saved from a well as a function of the number of years since the town was founded. Well, here, year 0 would be, the exact moment, the year the town was founded. And the number of people saved from a well, that can't be negative. You can either save no people or positive numbers of people. So this one can't be negative, this y-intercept here. Here, the height of the taller of two twins as a function of age. Well, again, height's got to be a positive number all the time, so even at age 0, the height of the taller baby. Again, if you think of the whole age 0 as being newborn, and you take the height of the taller baby, that's going to be a positive number. So again, this can't have a negative y-intercept. The number of people who have fallen into a well, plotted as a function over the again, the same thing. The number of people who have fallen into a well has got to be a positive number. So the only one here that could possibly be negative, if you interpret age 0 as just being newborn and then take the shorter baby minus the taller baby, that can be negative. That's the only one that makes sense that could actually be negative at x equals 0. All right. And again, got the answer explanation there. So, hopefully, watching me do this, looking at the more instruction when you need to, reading the answer explanations when they come up, I'm hoping all this stuff helps you out when you're working on this on your own. And I believe this is the end of this. Yeah. All right. And thank you very much for watching.